and we were discussing the step number 1. So whenever the question is asked like explain the steps in preliminary part P analysis, you have to write the way I am sharing. So the step 1 was establishing the general characteristics of the workpiece. So in which we have discussed what is general description of the part, what is general configuration of the part. So in general configuration of the part, we discuss how the components to be handled. So for that, you need to calculate the weight of the components. If the components are heavy, that is if it is more than 5 kg, then one person may not be sufficient. If the component is say 15 kg, then you may need devices like hoist, crane. Then you have to list the toolings. The tooling will include not only cutting tools, but it will also include jigs, fixtures. Most important in general configuration of the part, you have to list the sequence of operation. That is right from raw material receipt to the dispatch and rate of production. Rate of production here, you are not doing any calculation. It is based on your judgment. See, every time it is not possible to calculate or measure. So that time your inference or estimation or
Hello,
judgment.
sir.
Yes.
Sir, some students are waiting to join.
So many times this inference or estimation or judgment helps. हम लोग बोलते हैं ना अंदाज. So here you have to infer roughly what is the production rate. Then next is material. So you have to identify the material, whatever is given in the drawing, whether it is available or not. Then step number D in step number 1 is how the part is originated. This is very important. How the part is originated. How the part is originated means what is the basic process which is giving shape to the product. What is the basic process which is giving shape to the product? That is what is called as the how the part is originated. Like whether the part or the component is cast or whether it is forged or whether it is produced by rolling or by extrusion or by drawing, that has to be identified at this stage. In recorded changes in the design, are there any revisions? Are there any changes that you have to look? Many times in the drawing, the revisions are mentioned. So your first step is to check what are the revisions in the drawing. Then resistance to damage in the process. Many times you come across with very delicate, fragile, thin components. And I told you that these components has to be handled very carefully. If if you don't stack them properly, or if you don't handle them properly, कैसे भी आप अगर फेंकेंगे उसको, तो they are likely to get damaged. So you have to stack them properly with the help of a mandrail, or maybe you will have to pack them in thermocol, or you have to provide the pockets in a wooden box, or you may have to provide wooden mandrels on which you can mount them so that they remain safe. So as I told, you have to handle it like newborn baby. So this is this thin walled component bush. Even if you apply little force, this thickness is 0.5 mm and the length is say 50 mm. Even if you apply little force, जो round shape है, it will become elliptical. That shape will get collapsed. Then step number 2 is auxiliary method of visualizing the part. Auxiliary method of visualizing the part. Some components are simple, some are complex. So for the simple component, if it is round component, only one view is sufficient to understand, to visualize the component, or at the most two views. But if it is prismatic component, three-dimensional component, or assembled component, then two views or three views may not be sufficient. So in that case, you may need 3D drawing of that components, or 3D view, or exploded view, or maybe models, physical models, or CAD models. If the components are complex, if the drawings are complex, then in this case, if you have physical models, or if you have CAD models, if you have 3D models, so the drawings can be understood faster. So that is what is you have to write in auxiliary method of visualizing the part. Then third step is determine the principal process. Determine the principal process. Principal process means there may be many processes like turning, milling, drilling, grinding, heat treatment, broaching. There will be many processes in order to complete that component. Out of these so many processes, you have to see which process consumes maximum time. For example, suppose a gear, 40 teeth gear. So what will be the different processes in this? Basic process will be forging. That is the blank or the raw material is in forged condition. Then you will do raw material inspection. Then you will turn the blank. In turn, that is you will turn the OD, you will turn the ID, that is bore the ID and facing. Then obviously it will have some keyway, so that you will do it on slotting. And then teeth cutting, that is 40 teeth cutting. And then final inspection followed by packing and dispatch. Now out of these, if you see, gear teeth cutting, that 40 teeth cutting, that process will obviously consume more time. So in this case, in this particular component, your principal process will be gear teeth cutting. Like that, some components may have say 15 holes or 20 holes, tapped holes. So in that case, your principal process will be drilling and tapping. Or in some components, majority of the time will be taken by turning process. So in that case, the principal process will be obviously turning. So this is what is your determine the principal process. There is a reason for writing this step or for identifying this. Once you understand what is the principal process, then you have to focus on principal process. Your main focus will be on principal process. How to reduce the time of the principal process. Like I gave you an example of gear. So here principal process is gear teeth cutting. So you will focus as an engineer, you will see how do I reduce the gear teeth cutting time, because that is what the major process is. That is what the principal process is. That's why you have to identify the principal process. That is your step number 3. Then you have your step number 4. Step number 4 is determine the alternate process. As a process engineer, the requirement of the process engineer, we have already discussed that he should have knowledge of different processes. So the requirement of the process engineer that he should be well aware of different processes. Like for example, a hole is to be finished. H7 tolerance. Okay, let's take example of say hole 25H7. So you know capital H7, that is for the hole based system. So 25H7 will be somewhere around 18 to 20 microns tolerance plus side mein on 25. So what are the different processes to achieve this 25H7, 25 plus 0 plus 18 micron? Obviously drilling not possible. You have option of reaming. You can do it by reaming. You can do it by finish boring operation, that is using micro boring tool. You can interpolate also on milling machines, do the interpolation, but then interpolation may you may get OLT, or you can broach it. So these are the different processes, alternate processes. ये नहीं है this नहीं है this. लाइक आप होटल में जाते हैं, चलो ये है क्या, नहीं, चलो दूसरा क्या है, तीसरा क्या है, like that. So similarly here you should have knowledge of various processes, how the same component can be done by different processes, and out of which you have to select the most suitable depending upon the quantity, depending upon the material, and depending upon the product requirement, and of course well within the budget, that is your budget constraints. For example, like suppose if you want, you can finish the bore very well by broaching, it will be fastest operation. But then if you want to have a broach, that itself will cost around 1 lakh rupees. So you have to have a trade-off between the cost, quantity, tolerance, all these factors as a process engineer you have to consider. But you don't have to worry about budget, etc. at this point because that is not within our scope. You have to simply think of the alternate process. The intention is that whether you are aware of different processes or not, whether you know the whole can be faced by broaching or not. That is the intention. Budget, etc., that comes later. Economics will come later. In step number 5 is determine the functionally important surfaces on the workpiece. What are the surfaces which are important? See, we are doing the postmortem. We are reading each and every line. We are reading each and every word. We are reading each and every character. So what are the functionally important surfaces on the workpiece, on the component? So how you will determine? So there are three things. That is based on the geometry, that is based on the geometrical tolerances. Geometrical tolerances means you are aware, by this as a third year students. Based on the geometry means many times it is mentioned in the drawing. This surface perpendicular to like A perpendicular to B within 0.01 or A parallel to B within 0.015 or A at an angle or A concentric to B. So you have to look for these tolerances which are mentioned on the drawing. So that is based on the geometry. So whenever like it is said that A should be concentric to B within 10 microns, that means obviously you have to pay special attention to that. Yes, those two surfaces are functionally important. अगर ये दो surfaces out होंगे तो चलेगा नहीं. They are functionally important because bore and OD, they should be concentric. That means that particular piece is going to be mounted on a shaft. Shaft is going to be driven, and on the OD something else is going to sit, and that should run true with the shaft. It should not run out, or at the most, if it is running out, it should run out within 10 micron. If it is running out more than 10 microns, then it is going to damage. So that is what is functionally important surface based on the geometry. Another criteria is based on the surface finish. You know by this time that how do you show the surface finish? One triangle or the symbol of sine wave, two triangles, three triangles. Sometimes the RA value is mentioned. Surface finish, what is surface finish? It is basically the difference between the high point and the low point, isn't it? The peak and the valley, that distance. Good surface finish means what? That distance between the peak and the valley, that has to be reduced. Ideally, it should be 0. So, moment we say 3 triangles or moment we read 4 triangles, that means immediately it strikes to us, yes, this is a ground finish or this is a lapped finished. That means this surface is important. Something is going to slide on this, or it is a working surface. Hmm? Like say cylinder and piston arrangement. Hmm? So those are all lapped. The cylinder bore, engine ka cylinder bore is lapped always. It is lapped. Why? Because piston is sliding inside there. So based on the surface finish, you identify this is functionally important surface. Another is third. What is third criteria? Based on the tolerance. See, first was geometry. Geometry means squareness, perpendicularity, angularity, concentricity, parallelism. These are called as based on the geometry. Surface finish means three triangles, four triangles, two triangles. Tolerance means, like suppose a bore is to be finished. We need tolerance. Without tolerance, we cannot work, isn't it? There is nothing like 0, 0. I cannot say that the size of this bore is 25.0. Means neither you can measure 25.00, neither I can measure. See, if I tell you that come at 11 o'clock dot, so the probability of reaching at 11 o'clock may be very less, 1% or 2%. But if I say come between 10:55 or 11.00, come plus or minus 5 minutes, the probability may be 80% reaching in. So same thing is manufacturing. You cannot manufacture 0, 0. There are a lot of factors: machines, materials, man, tools. So like suppose a bore is given say 100.00 plus or minus 0.04. So moment you see, or if you say same example 25H7, so 25 plus 0.018. So moment you look at the tolerance, this tolerance is closed. That means again it is going to be functionally important surface. That means something is going to fit inside this. So you have to pay a special attention. You have to be careful. So determine the functionally important surfaces on the workpiece is based on these three criteria, that is geometry, surface finish and tolerance. And it is very simple. If you look at the drawing, you will come to know. And we are going to study one drawing. Then step number 6, determine the areas used for processing. Determine the areas used for processing. So you have to identify which areas are suitable for locating, which areas are suitable for clamping, which areas are suitable for supporting. So these are the three areas you have to identify looking at the drawing. Where do I locate? Where do I clamp? And where do I support? It appears to be same, or it may happen that all three can be one in some components, or all three can be different also. Let us take an example of this bush which is shown. Take a closer look here on this bush. Now this bore is finished to diameter 25H7. All right. And it is mentioned this OD, that G stands for grinding. This is another way of showing surface finish. And bore is ground. And you want OD to be concentrated with ID within 0.04. That means obviously you will have to locate on the bore. We have to do this OD grinding with respect to bore. Then only it will be concentric within 20 micron or 40 micron. Means you have to do this in one setting. So here the location has to be bore. Where do you clamp? Clamping means you should understand that if I am going to clamp, that means it is going to give some marks on the surface where I am going to clamp. So if the surface is not that important, so I can clamp over there. Then support. Now in this case, I can clamp on this OD and I can give the support to this face. This face. I will give the support to this face. So even though it appears at one instant that clamping and supporting is it same, but it is different. Means here When I say clamping means I am applying a force. Understand? And supporting means it is just giving a support, and essentially there is no requirement of force. Whereas in clamping, there will be a clamping force so that your component doesn't fly off while you do machining. So this was your locating, clamping and supporting. Then step number 8, that is specifications, implied and explicit. So there are two types of specification, implied specification and explicit specification. Implied specification means they are not specified on the drawing, it is not given on the drawing, but we have to identify. That has to be identified by the process engineer based on his knowledge or by convention. Like suppose a drilled hole is shown in a component, diameter 10 hole. So obviously the axis of the drill hole should be perpendicular to the surface of the component, isn't it? By default. It is expected, even though it is not mentioned. You cannot expect the axis of the hole at an angle to the surface. It has to be parallel to the axis or parallel to the center line. Explicit characters means implied characters means what? It is not specified on the drawing, but you need to identify. Burr, the components has to be burr free, isn't it? It's not necessary to write it on the drawing that produce burr free component. It is understood that there should not be burr. You cannot say अरे उधर लिखा नहीं है बर नहीं चाहिए तो मैंने बर which बर components produce किया. No way. Explicit means it will be clearly stated. It will be clearly mentioned on the drawing. Like what should be the concentricity, what should be the parallelism, what should be the surface finish, what are the gear manufacturing details, what are the heat treatment details, that is heat to so many degree, soak it, cool it, like that. That will be stated on the drawing. That is what is explicit specification. Okay. We'll continue this journey next class में. Sorry for extending. I'll just quickly take the attendance. बोबड़े,
Present, sir.
प्रसन्न, अनिकेत, यश, रेनन,
Present, sir.
शुभम,
Present, sir.
सिद्धांत, हसनैन, वेलेंका,
Present, sir.
ऋतिका,
Present, sir.
अमोघ,
Present, sir.
अद्वैत, उपकार,
Present, sir.
विशाल, ओंकार, हर्ष, सबन,
Sir,
शर्मा,
Sahil present.
सबन, शर्मा,
Present, sir.
धीरज, माधव, डिम्पल, प्रणव, शनि,
Present.
अली, प्रशील,
Present, sir.
उमंग,
Present, sir.
विवेक,
Present, sir.
ऋषिकेश, एहसान, सलमान, प्रथमेश,
Present, sir.
सलमान,
हाँ सर.
कुनार,
Present, sir.
जोएल,
Present, sir.
सैमसन,
Present, sir.
शेल्डन,
Present, sir.
विशाल,
Present, sir.
अभिषेक, मुखरी, ऋषिकेश,
sir. Present, sir.
ऋषिकेश, आशीष,
Present, sir.
नीरव,
Present, sir.
ऋग्वेद,
Present, sir.
ध्रुव,
Present, sir.
वसीम,
Present, sir.
ओमकार, पोल, हिमांशु,
Present, sir.
आदिल,
Present, sir.
दीपेन,
Sir.
आकाश, ध्रुव,
Sir, Shivam present.
शुभम, ध्रुव, मंथन,
Present, sir.
Manish, Sumit. Okay, thank you. Any doubt?
Sir, Sharman Mole
No,
Sorry,
sir.
present. Sir,
Sir,
Sharman Mole present.
come again, loudly. Hello.
No doubt, sir.
Okay.
Sir, Sharman Mole present.
Who is that?
Sharman Mole.
Okay.
8791.
Wait. What's the number?
8791.
ठीक है. Okay, thank you.
Thank you, sir.